Welcome to the second video in Unit 8. We're going to be continuing our study of fractions in the algebra world. We're doing something called complex fractions, but what I want you to know is that this is just division of fractions. That's really all this is. It looks complicated, but it really isn't. I'm going to show you a couple of different methods. I, of course, have a favorite method, but as usual, you can always do these problems in more than one way, and so we're going to look at different approaches. So let's do a little bit of analysis of a complex problem, okay, a complex fraction. And so what that means is that you can see here that you have a fraction. This is the numerator of the fraction. This is the denominator of the fraction. So this is the main fraction division of the two fractions, right? So we'd have this divided by this. Within the numerator, we also have a fraction. That's why they call them complex fractions, because you have a fraction in the numerator, fraction in the denominator. But if you wanted to simplify it further, you could do just like it says over here. It would be the same thing as dividing 3/4 by 2/3. And remember, when you divide 3/4 by 2/3, it's the same thing as doing 3/4 times the reciprocal of the denominator, which is 3/2. So when you multiply across, you end up with 9/8. It's not a big deal. So over here, if we had this top fraction, which I'm rewriting as is, and that would be multiplied by the reciprocal of the bottom, the denominator, and that's it. The division problem becomes multiplication. And we know from doing these previous problems that you would factor everything and you would be able to cancel using forms of 1 each of the fractions that you would find. But it's the same principle. That's what we're after. So method 1 would be to find a common denominator for each, the top and the bottom, if necessary, and then treat it like a division problem and flip the bottom fraction and multiply it. So you would turn it into a multiplication problem. So in this instance, they're using real numbers, so let's just go with that. In the numerator, remember that 4 is just 4/1. And in the denominator, you can see that the common denominator is going to be 4. So what I would have 3 minus, well, 2 times 2 is 4 times that would be 6. So I end up with 4/1 over -3/4. Then I would have 4/1 times -4, over 3, which would give me -16/3. And so that's how you do it. It's pretty simple. If you have trouble with the algebra, if you'll go back to numbers, it makes it a little more simple so that you can understand the concept. The second method would be to find one common denominator for all the fractions in the expression and then multiply both the complex numerator and its denominator by that expression. Now in this case, because this is a number, then the number would not be, the expression would be a number. So for instance, 5 is a factor of 25, but not 16. So the common denominator down here would actually be 25 times 16, which I believe is 400. Yeah, I took a quick break and checked that on the calculator. It is 400. So what we would do is we would multiply the top and the bottom by 400/1. So that's what I'm going to do. So this would be the top times 400 and the bottom times 400. Okay, so I know that 5 goes into 400. I want to say 80 times, and that's true. So this would be 4 times 80/1. And then here, this would be 400 divided by 25 would be 16, obviously. So this would be 2 times 16 minus, and then 16 goes into 425 times, and 25 times 5 is 125. 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 Okay, so that's going to end up to be 320. This is a lot of numbers, huh? So 125 minus 32 is, so over negative 93. Holy cow. Okay, so that's a lot of reducing. So my favorite method, of course, is the first one. But there are a lot of students who, when we get into the algebra, like the second method. So we're going to do a little of both. Okay, so on this one you can see it looks an awful lot like the very first example where we found a common denominator for the top and a common denominator from the bottom and then treated it like two fractions. So that's how I'm going to start this off. So I have x over 1 on the top, and then since these are the same, this is 3 plus 1 or 4 over x. That would give me x over 1 times x over 4, which is going to be x squared over 4. So that's how you do that one. Now, be real careful here, because weren't you tempted just to do this? X over 1 times 4 over x, and the x's cancel, and it's just 4. But that's not correct. So be careful, you'll be tempted. The other way to do that is if I just multiplied the whole thing by x, because that's the common denominator for the whole fraction, right? So if I did this and I multiplied the top by x and the bottom by x, remember that's just a form of 1, then the top I get x squared. The x is going to cancel here because this is going to be 4x over x, right? So this ends up being x squared over 4, and you get the same thing. So that's two methods in a nutshell. Okay, so this is really what these problems are going to look like. Okay, so what I'm going to do is I'm going to do the first method on this problem. So what I'm going to do is split it into the top and the bottom. In the top, my common denominator is going to be the two of them multiplied together. Okay, so I would have 16 m minus 1 m minus 4 minus 4 m minus 3. That's what I'm going to do on the top. On the bottom, my common denominator is m squared m minus 3. So up here, I'm going to have 16 times n minus 3 minus m squared m minus 4. Okay, so I have a lot of reducing and all that kind of stuff, simplifying. So I'm going to go ahead and multiply through this and get some things simplified on the top and bottom. In fact, I may just write them over here in black, just give myself a little work room. 16m minus 64 minus 4m plus 12. That's here on the top. On the bottom, I'm going to have 16m minus 48 minus m to the third plus 4m squared. That's down there. All right, so I end up with 12m minus 52 is what I want to say, over m minus 3, m minus 4, all over, was that negative? Yep, negative m to the third plus 4m squared plus 16m minus 48, all over m squared m minus 3. So remember what you do with the fractions. I'm going to take this, I'm going to change colors, and multiply it. So I do m squared on the top, m minus 3. I'm just going to leave it separate because something's going to cancel, over the bottom. Okay, so I can see the m minus 3 and the m minus 3 cancel, and I'm going to be left with m squared 12m minus 52 over m minus 4 plus the rest, or times the rest. And that's the answer. Whew. So that's really long, right? And that's doing it finding common denominators. But what I could have done is I could have multiplied all the way through by the common denominator of m squared, m minus 3, m minus 4, and that might actually have been a lot simpler. So I would like for you to try that before we get back, and see what you think. You have this problem, the original problem. So go ahead and try it where you multiply each fraction by this in the top and each fraction times that in the bottom. Now, the answer may not look exactly the same because some of this got multiplied through. But anyway, that's what we're going to do first thing when we come in. So have that written down and ready to go, and I will see you in class.